Okay, hello folks. We are just going to start just the very front page of this section 2.5 in chapter 2. We just had our test over the first half of this chapter, and so we're going to just take a look at what higher order derivatives is referring to. I know that we've talked about how to take a derivative of an original function, and what a higher order derivative is it's when after you found the derivative of an original function, you then take the derivative of the derivative, and we call that a second derivative. If you were to take the derivative of that, that would be called the third derivative, and so on. Now, it sounds like that might be something that could be complicated. I think you'll see in these first few examples that we're going to look at, actually becomes easier and easier and easier as you take higher order derivatives. That's not always the case, but with these first few examples here, you're going to see that here's our original function. Okay, and you can see there's a single apostrophe here that's just asking for the first derivative. Then they put two apostrophes there, that's the second derivative. Once you get past about 3 apostrophes, it starts to get a little complicated looking at 4 apostrophes. So a lot of times they'll just put a little 4, like in this notation here, or 5, so on. Okay, so if we were to say what is the first derivative of that original function, you guys are all really comfortable and do a really good job at what we call the power rule. Okay, keep in mind that this minus 7 would just zero out. So there I was just taking the derivative of each of those terms separately. Okay. Now if I'm going to do the second derivative, that would be now I'm looking at the first derivative and I'm taking the derivative of this. Okay, so now for my second derivative, that would be a 6x minus 12, and you'll notice that this constant would then zero out. Okay, now if I were going to do the third derivative, I would be looking at my second derivative to get the answer, which would just be 6. This would zero out. And for the fourth derivative, I would be taking the derivative of 6, which is a 0. So actually, any derivative from the fourth derivative on, my answer would just be 0, because the derivative of a constant is always 0. So from this point forward, it's all going to be 0 for this particular function. Okay, so let's go ahead and try another one here. Here's the original function. Our first derivative would be 3x squared minus 2x plus 1. Second derivative, 6x minus 2. Third derivative, 6. Fourth derivative and beyond, 0. And that was just a coincidence that these were exactly the same here. Okay. All right, so that seems pretty simple. Let's look at one that's just maybe mildly more complicated, but still not too bad here. Okay, in this next example, they're asking us to find the first 5 derivatives of, and here's our original function. Okay, I would encourage you to, rather than doing the quotient rule, let's pull that x up to the numerator so that this is actually what we're going to use as our original function. Okay, so I'm going to go ahead and just kind of show here our first derivative. We would pull that -1 in front, subtract 1 off of the exponent, and then do be careful when you're writing your answer down here in the box, make sure that you're setting that x squared back down in the bottom. We're going to try to follow the rule of putting our answer back in the original format that the initial problem was in. Okay. All right, so there's our first derivative. Now we'll go ahead and say, okay, what's the second derivative? Now I think what you'll want to do is, rather than looking at the problem here, let's look at the problem before we put that x to the -2 in the bottom, because we just need to pull it back up anyhow. So we're going to look back up here at our work and say, well, now if I pull that -2 in front, and there's already a negative there, that's going to be a +2. And now my new exponent is to the -3rd. Okay, same thing. When I write my answer down here, though, I'm going to write the answer with the x cubed in the bottom. All right, now we're going to go to the third derivative, but we're going to look back at our step right here where it's already pulled up to the numerator. That's going to be -6x to the -4th. Then we'll set it back down in the bottom. All right, now we are to the fourth derivative. Looks like that'll be 24x to the negative 5th, setting it in the bottom. And then finally, the 5th derivative. 24 times negative 5 is negative 120. Okay. So that one, it wasn't quite the same as this one, where it just felt like at some point, it just kept getting easier, easier, easier. But still, that wasn't too terribly bad there. You kind of get the idea of sort of how to walk through that. So we're just going to look at one last example here at the bottom, and then I have a really short assignment for you to try just over problems that are similar to these on the front page. Now you notice instead of the first 5 derivatives, this is just asking us to find the first 2 derivatives of this original function. Okay. Also take note that since the original function had a negative fractional exponent, I don't have to move things to the denominator. I don't have to switch things back into a radical. So I'm going to go ahead and pull that negative 1/2 in front, okay, next to the 16. I'm going to subtract 2 halves from negative 1/2. That'll make this negative 3 halves. And then I'm just simply going to kind of clean this up here. 16 times negative 1/2 would be negative 8. And I'm not going to move anything to the denominator. That way my answer is kind of looking the same as the original. Okay, there's my first derivative. Now if I were to do the second derivative, I want to be looking at this answer when I'm coming over here to do the power rule. I'm doing the power rule of that. So I got the negative 8. I'm going to pull the negative 3 halves in front. Now I'm subtracting 2 halves from a negative 3 halves. That's going to make that negative 5 halves. Okay, here again, I'm going to multiply. It looks like I'm getting 24 divided by 2. Okay, 24 divided by 2. That would be, I'm just going to write the answer here. That would be 12x to the negative 5 halves. Okay. The problems that I would like for you to go ahead and try here are on page 155, and it's really just 3 problems here. I want you to just try 1 through 5 odd. So 1, 3, and 5.